A big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast, we cover topics such as engineering, artificial intelligence, neuroscience, and other interesting topics to educate, inspire, and engineer people's minds all around the world. I'm your host Yusuf, and for this episode of the podcast, I'm very happy to have Alex Tamkin on my show. Alex is a third-year Ph.D. student in computer science at Stanford, advised by Noah Goodman, and part of the Stanford NLP Group. His research area is machine learning, especially applied to natural language processing. Recently, he has been thinking about curiosity, abstraction, and transfer in unsupervised learning. In the past, he has worked on projects in reinforcement learning, HCI, and computational astronomy. Alex also spent time at Google Brain, Google Language, and Google Civics. In this episode, Alex and I talked about life and work as a Ph.D. student at Stanford, NLP research, the democratization of AI, explainable AI, hardcoding values into AI systems, and we discussed the theory of one of his latest research papers using representation learning, and much more. For updates on upcoming podcasts, projects, and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter, engineeredmind.sh, where I share exclusive content, visit yusuf.substack.com. And now, ladies and gentlemen, here's my great discussion with Alex Tamkin. So, Alex, welcome to my podcast. It's really a pleasure to have you on the show.
Thanks for having me. It's great to be here.
Very exciting. So, as usual, we kick things off with you, Alex, giving us like a 1-minute bio. Who are you? What are you actually doing in life?
Yeah, so I'm a PhD student in computer science at Stanford. And basically, I study machine learning, especially unsupervised learning and natural language processing, with a sort of aim or interest in making AI systems more generally flexible and computationally efficient and easier to sort of understand and control. And in the past, I've sort of worked on a whole bunch of different things, including human-computer interaction, reinforcement learning, and I also did a summer trying to detect exoplanets with deep learning. And I'm also just kind of really interested in science communication, policy, societal impacts of AI, and just sort of better bridging like those different worlds.
A lot of interest. I really like that. Can you talk about your work as a PhD student or researcher? How is work as a PhD student or researcher? What would you advise people who want to go into the same field as you are in, if they want to do a PhD, for example?
Yeah, I mean, I think like the PhD is a really great opportunity to just get like a sort of period of time where you can really go deep into a particular field or area. And you can, I think, just get like the level of depth in, understanding what are the core problems, what are the solutions, what are the limitations, is really like so different from when you're just sort of taking classes and sort of getting this material that's kind of very nicely packaged and, all the homework problems have answers to them. And I think, the PhD is super different because it's just the wild, wild west in that way. So it's pretty, I think, exciting in that way. So if you enjoy that kind of total unstructured types of problems, it's super fun.
Yeah, and I guess what a lot of people are interested in from the audience is, do you need a PhD to do AI research? What would you tell them?
Yeah, I definitely don't think you need a PhD. There's a bunch of different companies or places where people are doing great research with, a bachelor's, master's, or even, not going to college. I think the PhD does, tend to open up certain doors, I've heard, and gives you really good training in order to sort of become an independent researcher in that way. But, there's a lot of different paths to doing interesting work wherever you go.
Mm-hmm. What I would be also interested in, I think it's also exciting for the audience to know, is you working at Stanford, you're surrounded by, I would say, geniuses all the time, yourself included, of course. How do you handle that, knowing people who are sometimes even smarter than you or appear to be smarter than you? How do you manage also work-life balance, which is like in turn affected by this, because you want to keep up with them somehow, but you also want to have like a private life? How do you manage that personally?
Yeah, I think one thing is just sort of really striking when you just join, a seminar or a program is like all the different questions that people are asking and all the terms that people are throwing around that you don't know. And I don't know. I think everyone has their own areas of knowledge, their own places that they're more comfortable in, and you get to a point where it's like it's sort of a benefit, right? Not a downside. That wow, like you know so much about this, like you can teach me. I'll talk about this, and it's a tough shift, right? When you come in and you just hear all these like questions and terminologies coming in that you you don't know what they mean, but I don't know. In the end, people are just human, right? And people are kind and nice and willing to share. And I've definitely found, that to be a real big positive, even when there's these people who just know, 100 million times more than me about particular things.
Yeah. How do you personally manage that? Like, for example, when it comes to work-life balance, no matter if this term now exists or there's some controversy around it, there are only work-life choices, some people say. How do you personally manage that as a researcher?
Yeah. I mean, for me, I think like at a certain point, it's just like knowing myself, and like at a certain point, I just get to a point where I know I'm I'm not going to be able to do any more work for the day. I need to draw, or I need to go for a walk, or call some friends, and I don't know. I really think that there's like a nice synergy between when you're most productive often, and when you're sort of most like feeling healthy and good. And yeah, for me, it's just like I can't work 14-hour days nonstop. Maybe before a deadline or something, but yeah, I need to get out, get some fresh air, hang out with friends, cook, that sort of thing. So,
yeah. That's super interesting. Do you think that all the activities you do around research, which also includes taking, doing photography, and also, what was the other hobby? I forgot the English word for it. I'm sorry.
Ceramics?
Ceramics, exactly. Do you think that that also benefits you in terms of being a researcher, to calm down, to ground yourself in some sense?
Yeah. I mean, I definitely think like it's just like the best feeling in the world after typing on a laptop for a while to just like play with clay, right? And it's completely different type of like tactile experience, and like type of thing you're optimizing for, feels like it works a totally different part of like the mind, and yeah, I don't know, it just feels like I can't prove it, but I feel like it makes me sort of more creative in certain ways, or I'll often have some ideas when I'm on a photo shoot, or working with making a big pot or something like that. So yeah, no proof, but it definitely feels like it helps me take a step back, think about the bigger picture, and I don't know, just like fun for its own sake. I don't know.
Mm-hmm. Of course, it's not possible at the moment to do some kind of socializing, but do you think being involved in NLP research and socializing yourself helps you also to understand the theory of NLP a bit more? So by saying, maybe it sounds a bit odd in the first place, but the more you socialize, the more you understand how language works and how you could possibly implement knowledge from real life into the NLP research.
I definitely think like being exposed to a bunch of different people who think in different ways, who talk in different ways, who different parts of the world or different cultures, like definitely makes you appreciate how certain assumptions you might have had about language just like totally don't, pan out. Just the like some, one really interesting phenomenon is how people have some languages have one word that in other languages are sort of very different words. And, just realizing that, wow, the word to know in English, that it could correspond to like, two different kinds of knowing, or even more in other languages. Like, I think that's sort of pretty fun and interesting, and makes you think, oh, I maybe some theories I had about, the type of cognitive skill that's needed for, this type of language activity or this type of cognitive task is actually really different than you might have thought initially.
Yeah, that makes absolute sense. And one aspect we want to talk about also in this podcast is ethics, which we come to at a later point. But talking about NLP, there are these big models coming up or currently super trendy. For example, DALL-E, if I pronounce it correctly, GPT-3, which we all know about. Where do you see these big corporations like OpenAI working on these models, having access to huge amounts of data, models, but also computing power? Do you see this as a kind of problem? For example, me as a small researcher, quote unquote, not being able to maybe access the API from OpenAI. Do you see that as a problem?
Yeah, I mean, I think it's kind of a really interesting shift that's happening where you have these developments of like, these much bigger, more ambitious projects that require a whole lot of compute, and the outputs of these models can do some really amazing and interesting things. But yeah, it does make it sort of less accessible in some ways, and I think there's some really tough trade-offs, right? Because these models are really powerful, and they might have sort of side effects that, or even just sort of uses or misuses that we're not aware of. And so maybe it makes sense to be a bit more careful before deploying them sort of the most broadly. But then on the other hand, you have this sort of whole access and fairness issue, which is like, in order to understand these models, researchers, not just from the huge institutions, but from all over, need to be able to access them, to test them, to play with them, and then also to, develop and improve them. And so I think it's a challenging balance, and one that, hopefully not just individual institutions will make, but that sort of the scientific community as a whole will sort of have some way of coming to a consensus about. But yeah, it's not sort of a cut and dry issue, and it's challenging.
Yeah. Also, I saw in one of your tweets that you even mentioned, which was surprising for me because I'm not too much into NLP, is that actually OpenAI, for example, they are using quite not very new techniques. They're using established systems, but they're very good at data engineering, or like engineering the systems itself.
Yeah, I mean, I think one of the things that people think of when they think of AI is like modeling, right? Where you sort of develop and come up with new models, but it's really only one picture of the types of like creative research that you can do. And I think the data-ing is also sort of incredibly important and creative, and a super valid contribution. So it's not that it's not a creative or innovative research. Is incredibly so, but I think a lot of that creativity comes from sort of means that people have neglected a little bit. And so I think the algorithms are sort of especially for GPT-3 really similar to things that people have studied for a fairly long while, but the types of properties that emerge, at this sort of enormous scale are quite different, and that's pretty interesting.
Yeah, what also maybe comes with a scale, maybe probably know way more than I do, is that explainability becomes also a bit harder, I would assume. And with the models, I would assume they're always biased. I'm not sure how you see it, but how would you explain such a system to make it explainable and make it transparent, so that it makes maybe a wrong decision in the future, understanding why it made that decision? If it's now GPT-3, for example, writing an article for a magazine, which could be in the future. How do you see that?
Yeah, I think that's one of the most sort of interesting questions of AI and actually just science in general for me, which is that we have these incredibly complex systems that are composed of millions or billions or trillions of interacting parts, and somehow there's this really interesting emergent behavior that occurs. But how can you summarize or describe or create some sort of useful model of that incredible complexity, such that it's useful to humans? When we build complex systems, we generally start with this sort of like simple schema and maybe build out sort of complexity in a very regimented way. But a lot of natural systems aren't like this, and maybe neural networks are pretty similar. And so I think that's just a really challenging and hard problem, especially when it comes to systems that are possibly going to be making important decisions about resources. It's about all sorts of things in the world, which is what these systems might sort of start to become used for. So yeah, I think it's an enormous challenge, and there's a whole bunch of people working on different approaches, thinking about changes we can make to the training data, to the algorithm, to monitoring. But I don't think there's really a silver bullet yet. So it's, an incredible area for future research, for, people, just because there's these humongous models and I can't build them doesn't mean that, there needs to be a lot of innovation in order to make these models useful, accessible, trustworthy, and actually practically have positive impact in the world.
Yeah, I got it. Also, when it comes to maybe hard coding rules into the system, do you think that will be possible? Do you think even it makes sense, especially when we come to hard decisions? Because let's say a decision in the US might be completely decision as an average population of the average population in China or Europe. How would you tackle that?
Yeah, that's enormously challenging too, because not only do cultures sort of have differences and also sort of countries, but there's incredible variation within different societies. And I think in terms of hard coding, there's certain cases where maybe a bit less in NLP, but certainly in if you're making decisions about healthcare, right? There's very clear, guidelines or things that you can and can't do that maybe are a lot easier to program into some of these systems that might at one point make medical decisions. But I think it becomes a lot more challenging, just like you're saying, when you have these sort of complex and fuzzy terms that have to do with language and the way that language is presented and how these computers interact with people and what fair interactions mean and what respect means. It's really challenging, I think, when you try to hard code some of these things in.
Yeah. Let's assume you would be an alchemist and you are looking for the Philosopher's Stone in NLP. What is the Philosopher's Stone in NLP? What's the biggest problem? What would you say? There are so many, I guess, but what is the Philosopher's Stone? What would you say?
Yeah, I mean, I think one generally really hard problem in AI is when you have a super complex and powerful system, how do you actually get it to do what you want, right? And I think the really amazing thing is that humans, we make it look so easy. If you and I are communicating and working together, then, we can talk about our goals, the things that we want to do and accomplish in a project. And, we can sort of align on a core set of values or a mission. But that's really, really hard to do with these systems. You'll give them a data set, right? And they'll do really, really well on that data set, which you think has to do with, understanding reading comprehension or something like that. And then they'll go off into the world and the data will be a little bit different. To humans, it looks sort of very similar, but these systems will sort of crash and burn and really do horribly. And so I think one of the really important questions is when we have these humongous powerful systems, how do we actually make sure that what they're doing is sort of in line with what we as humans want them to be doing.
Yeah, also this podcast is, of course, with you being in focus. Why did you choose NLP in the first place? Is this this subconscious knowing that people are basically communicating by seeing, so with that I mean computer vision, but also by talking, by communicating? Is it something you feel connected to in some sense? That's why you chose NLP in the first place?
Yeah, I mean, I think, I think a lot of the fields are sort of blending together a little bit in some ways because of the different, the same sort of tool. A lot of people are using similar tools in these different fields, and a lot of the similar questions are sort of coming up. But I think what's amazing about language is that it's just incredibly flexible. It's sort of the communication between people. It's kind of one of the core fabrics that societies are built on. Human knowledge is crystallized in language throughout generations. It's I think there's just a lot that's really interesting about language, about meaning, and about a lot of, I think, what makes us human. I think language is pretty cool.
Yeah. What is the latest paper you have worked on? Was it representation learning?
Yeah. So I had a paper recently that was on how do we do representation learning in a domain agnostic way, which we can get into a little bit.
Yeah, sure. Maybe you can get started by explaining what does representation learning even mean?
Totally. So you can think about one way to teach a neural network is to give it a whole bunch of examples of like some sort of data and then some sort of action or label that's associated with that data. So if you have a picture of an image, it might be like the breed of dog that's in that image. And then over time, these networks with millions of examples learn to label the image with, the type of dog it is. But humans, if we're sort of looking at a type of dog we've never seen before, we often don't need sort of millions of examples to learn that new dog. We've seen, we have all this prior knowledge about what dogs look like, what their kinds of ears and noses and faces and sort of spots look like, from just looking at seeing a whole bunch of different dogs in the wild, and also just sort of our prior knowledge. And so representation learning is sort of about how do we get these neural networks to look at a whole bunch of raw data in the world and pick out the sort of interesting patterns that they see without any sort of human feedback or knowledge sort of initially, which means that it can be scaled up to millions or billions or even more of images. And then when you get a new data point, like a new breed of dog that you see, you can leverage all of that prior context, all of that sort of knowledge about what dogs look like and ears and whatever, so that, if you see another dog, even if it's sort of different, you can get the similarities, and you can basically learn really quickly and efficiently. So you only need maybe a couple of examples or even one example, whereas previously you would have needed like a million. So that's the goal of one of the goals of representation learning.
Yeah, how does the representation learning aspect fit into this whole concept of NLP?
Mm-hmm. Yeah, so you can imagine, I just gave an example for images, but you can imagine for text also. Mm-hmm. There's just a huge amount of text, in all the books that have ever been written and in the internet. And there's, you might hope that, you could just get a machine to read all of Wikipedia, all of the, interesting knowledge in the internet, and just soak it all up, such that, if you have some other kind of language task, then the neural network would be able to learn it really efficiently and quickly, which might open up the doors to, using it a lot more easily and not having to acquire, tons of data. So that's sort of how it fits into NLP specifically.
I think tons of data is a good point, because how would you personally would love to see NLP being democratized, or maybe let's take the example of Delhi again, to make it accessible for, let's say, countries who are not that fortunate, people who don't have these huge machines or access to GPUs. How would you personally approach that, or would love to see the way this is going to?
Yeah, I mean, there's a couple of different things that you might see when you have sort of, if you have a big model that's really safe to deploy sort of broadly, you could imagine, pressing it somehow and pruning it and making it so that it's super efficient and can run on, a cell phone or something like that. Mm-hmm. That might be one approach, so that everyone can sort of have that model on their phones, or, even if you don't have a humongous, GPU or computing cluster. And the other way is to sort of make it accessible via some sort of API, where it runs on big machines somewhere else, but, just like you can do all sorts of things with your phone that don't require computing on your phone, you can maybe access and query the model that way. And then, the question is, how much does that cost? And, is it accessible, to people with a low internet connection? And there's a whole bunch of accessibility questions there.
Yeah, got it. Jumping back to the paper, what was the initial idea of creating this paper, or working on this paper of representation learning, and what was the outcome? Maybe you can go a little bit into depth here.
Yeah, totally. So I guess one of these questions with representation learning is, what's the algorithm? What is the task that this sort of neural network is learning on if it's not getting human feedback or labels during that process? And so there's a bunch of sort of recent successful algorithms to do representation learning for images, and they're sort of known as these like contrastive learning algorithms, because they have to deal with the sort of contrasts or relations between different images in the data set. But there's a sort of core aspect of this algorithm, which is the data augmentation, which is sort of what you take an image and you modify it in two different ways. So you maybe flip one image and change the color a little bit, and flip the other image and change the color in a different way and crop it. And so you get these sort of two different images, and you sort of have to, the network has to tell that they're the same image, right? That's sort of task. And it works really well for images, but it sort of requires a whole lot of human design and manual sort of labor and expert knowledge in order to create these what are known as augmentation functions, or these view functions. It's another term for it. And so our thought was, well, one of the goals of representation learning is you want to do this broadly for any kind of data, right? So maybe you care about images, images of natural, of animals. Maybe someone else cares about satellite images. Maybe someone else cares about audio or speech. Maybe someone else has a whole bunch of signals data. And so we wanted to come up with some sort of general approach that wouldn't require a whole bunch of humans to sort of come up with and design these different perturbation functions for how you sort of change the data, but also then would work not just for images, but for any sort of possible data more generally. And so what we did was, rather than just having one neural network, we have two. And this neural network takes in a data point and then learns sort of challenging perturbation functions. So basically it will output a messed up image, two different messed up images, and then this other network will have to tell that they're the same image. And so it sort of generally learns over time to come up with more complex and interesting and challenging corrections to the input image, which then sort of bootstraps this network to sort of have to build better and better representations to, tell that a dog is still the same photo of a dog, even if it doesn't have his head, or even if the color of the fur is changed a little bit, or even if, there's speckles or stripes in the background. And it turned out that it worked really well across sort of images, audio, and the sort of wearable signals data. And so we were kind of excited about, maybe this can sort of be a step in the direction of more like domain agnostic representation learning methods.
Got it. One example that comes into my head is something overcoming like adversarial examples. Is it something where you can use your approach for?
Yeah, that's a great observation. And actually, we look at this a little bit. So adversarial examples are obviously these sort of little perturbations to the image which totally change the class prediction. So the neural network thinks that this perturbation totally changes the image, but humans sort of don't think that at all. And what we showed was that for different types of corruptions, we didn't look at adversarial corruptions, but for different types of speckles or noise or changes in contrast, or if you sort of add like a glass blur to your image, that often the neural network trained with our approach can be a bit more resistant to those different kinds of unseen perturbations, because that's exactly sort of what it's doing. It's coming up with these perturbations sort of on the fly as you're sort of training, and has maybe a much bigger, richer diversity of perturbations than if you were to sort of design them by hand.
Got it. When it comes to NLP, I'm not very familiar with NLP itself. How would you measure the quality of a model? Because there are so many models, there are so many coming out. How do you measure a quality of an NLP model? And do you see a limit somewhere, or is it like always becoming a model out which is better than the last one? What do you think?
Yeah, that's a great question. I think that's actually a really important question in NLP right now, which is how do you measure models? Because I think it's multidimensional. If you just look at accuracy on some sort of new data, you miss out on a whole bunch of other factors, right? Like maybe efficiency or fairness, or the sort of how hungry it is for data. And so there's some people who are making benchmarks to sort of come up with different ways of measuring these models. And a popular one is this glue benchmark, which is sort of a consortium of different NLP tasks, and you sort of look at the average score of the model on a whole bunch of them. But I hope that we're going to sort of see a bit more diversity in the kinds of ways we evaluate these systems.
Where would you like to see NLP going for greater good?
Yeah, I think I really want to see people care maybe a little bit less about achieving state of the art on these benchmarks, and think about what are some other things that we're not measuring. What are some things that are maybe really impactful to people's lives, to the ways that these systems might end up being deployed, just like sort of dreaming bigger about the types of problems that we might care about, right? And I think a lot of people are doing this right now, and I think it's sort of only going to get more important, especially as these models get so big that they're hard to, for academics to discover ourselves. But I think really taking a step back and thinking about how are these models going to be used in the world? What are the needs? What are these sort of, features that we're not really thinking about right now, but that could really make a difference in terms of, societal impact, one way or the other.
Yeah, how do you personally see that as a researcher? Do you think it makes sense either to be a generalist or more of someone who is specialized in one field? Let's say you want to focus on NLP, but maybe it makes sense to learn more about neuroscience, psychology, ethics, philosophy. How is your approach here?
Yeah, I mean, I think for the PhD, you really do need depth in at least one area. But I think breadth, there's this sort of notion of like the T-shaped, scientist, where you have a sort of thin layer of broad-based understanding that covers a whole bunch of different areas. And then you have sort of the deep, you go really deep in one area. And there's also the sort of pie-shaped scientist where it's, that thin layer, and then you sort of are interdisciplinary. And so you have sort of expertise in a whole bunch of different areas. And I think, I guess I think of it more a bit like stalactites, those like those rock formations that come sort of down from the surface, where you sort of have a bunch of these different, areas in various amounts of depth, and different projects maybe draw on different pieces of expertise. And I think that's sort of, you're probably a lot more likely to, or at least I really enjoy that kind of fusion between, the interesting ideas that come from, what happens when we ask this question in this particular domain, or why aren't we thinking about this here? That's sort of what I feel about that.
Yeah, if someone is interested in learning more about NLP, what resources would you generally recommend them? Maybe your top 3, either if it's books, internet resources.
Yeah, I mean, I think the CS224N is this sort of wonderful deep learning course that's taught at Stanford. It was my introduction to NLP, and sort of Chris Manning has been really awesome at sort of putting together a course that's both like steeped in like the gives like deep background about NLP, but also sort of up to date with like the latest methods. Dan Adrasky, another professor at Stanford, has this really awesome textbook which he's sort of just updating and putting on the web that also has to do with NLP. And and I guess there's just sort of those are 2 that I think are really great.
Yeah, awesome. Do you think it's too late to jump on the AI train, if we call it that way?
I think that we're just getting to the point where a bunch of the really interesting ideas and problems in AI are just becoming like really apparent, and are sort of emerging from being these sort of theoretical problems that might happen one day, and they're actually being really important and tractable, right? Like these sort of problems of how do we get neural networks to do what we want them to do? How do we get these neural networks to learn efficiently? What does fairness mean? What does controlling a model mean? What does understanding a model mean? I think it's just like, in some ways, the questions that are going to come up in the next, maybe 5 or 10 years are maybe even more interesting than like the sort of questions in the last, last 10 years in AI.
What is your personal wish? Where would you like to see yourself maybe 5, maybe to 10 years? In your research, what is your wish?
Yeah, I mean, I think it would be great to try to pick one of these different areas and really sort of go deep into it and make sort of a series of like contributions, which maybe build up over time. And I don't know which exactly one that's going to be, because I think the field changes really fast. But if I can sort of make a contribution that people find interesting and care about and can build off of. I mean, that's just like the best feeling as a scientist, right?
Yeah. Is there some tips you would give to people getting started in NLP? What would you think, or what would you say are the biggest bottlenecks in NLP? What is like very difficult in the beginning, but once you get a hang of it, then it works?
Yeah, I mean, I think it's kind of different for everyone. So I would say don't get discouraged. I think for some people, like I think for me, the getting all the sort of details and the intuitions for how these like deep learning systems and neural network architectures actually work is really challenging. In part, I think because we don't really have good answers, and a lot of people build these sort of mental models of these systems through trial and error. So figuring out like what to do with my if my loss curve looks a certain way, if it's very bumpy or jagged, I think that's kind of pretty challenging. And so maybe my advice would be if you can work with someone, who has done it for a bit longer, you can maybe like skill share there. So that would be, I think, great. It's just always great to, I think, work with people and learn from people. I think another thing is if something feels hard or wrong or awkward, don't necessarily think that that's because you aren't just sort of good enough or there yet. Oftentimes that's because the thing really is hard or wrong or awkward, and other people just learn to live with it, right? And so I think like really treasure that beginner's mindset where you can ask really simple questions or questions sort of these like established ways of doing things, but that are actually sometimes really like piercing and great.
Awesome. So before we wrap things up, Alex, I have the question Rampage prepared for you. 10 questions, and optimally you answer them in one word or one sentence or two sentences if you like.
Okay.
And then at the end you can add anything else if you want or tell the audience.
Mm-hmm.
So question number 1 for you is, what are you most proud of?
I think it's sort of trying to be like, a kind person, I guess. Like, I think, that's something I, strive for.
Do you think it also has disadvantages?
It does. I think kind does not mean naive, but yeah, I think kind doesn't mean naive, but
Okay.
you can have both.
Okay. Question number 2: who is your biggest inspiration?
Ooh, I mean, my parents. Yeah, they're just like are so amazing and yeah, just like always are both amazing, like parents, but then also just like have such like they just go for it in their lives, and I don't know, just a pretty amazing models in that way.
Yeah. Best mentor you ever had?
Ooh. That's really hard. I think because I think mentors are really great in different ways. Mm-hmm. But I think I had a high school teacher who was, I think, a high school English teacher who was, I think, just pretty amazing in the ways in which mentoring and shaping. Yeah,
that's great to hear. Next question: you win $100 million. What do you do first? You cannot say I will train a NLP model.
I think I spend a lot of time thinking about the most important problems, and the ways that are best to spend it. That's an awful answer, but yeah.
Okay. Next question is favorite operating system.
Ooh. Linux.
Okay. One superpower you would like to have?
Ooh. I think ability to teleport.
This is cool. If you could spend one day with any celebrity, who would it be?
Einstein.
Favorite programming language?
Python.
Favorite AI framework?
PyTorch.
Okay. And the last question, what is the first question you would ask an AGI system?
What's the answer to the most interesting question someone could ask you?
This is a good one. I like it. Alex, I really appreciated you being on my show. Is there anything else you would like to tell your audience where they can follow you? Of course, Twitter profile, I will put it down in the description. Anywhere else maybe they can find your beautiful art?
Yeah, I have some of my art and papers on my website, which is just alextamkin.com. And yeah.
Great. Any last advice you would give people who want to delve into the field into AI and feel a bit overwhelmed?
Yeah, I would just say like start small. You don't have to learn it all. Just pick a small project, maybe something that's like meaningful to you, and build the sort of simplest possible thing, and that'll sort of be like a little bit of a kernel that you can sort of branch out from, and yeah, I don't know. Things accumulate over time, so you don't have to go everywhere. In just like the first week or month that you start studying AI.
Beautiful advice, Alex. I really much appreciate you being on my show again, and hopefully we'll see each other in the second part, who knows, in the future. And I wish you all the best in your research career, and hopefully we'll see each other soon.
Thanks so much. This was great. Thanks for having me.
Thank you.